Okay, concept 20 is graphing conic section. So number 6, we're asked to write the equation of an ellipse, and you're given some information here. Best way to do these problems is just to graph it, and once you have a graph of what is being described, it makes it much easier to write the equation of the ellipse. So in this specific problem, we have co-vertices given at -2, -5. So we'll plot those. So we have a co-vertex right here, another co-vertex right here. And we're also given a vertex, one vertex of the ellipse at -5, -4. So we don't have the entire picture of the ellipse, but we have enough to be able to figure out the equation. So if these are our co-vertices, remember co-vertices refer to, let's say you had a horizontal ellipse, co-vertices are the shorter of the 2 points. Vertices, each vertex, is at the longer of the points. So here, if these are our co-vertices, our center must be right in between those. So let's try to figure out where the center is. If this is at -2, -3, and this is at -2, -5, the center has to be right there in the middle at -2, -4. So we can start setting up our equation. We have x minus h squared, and we'll get back to the denominator in a second, plus y minus k squared, and we'll get back to that denominator, equals 1. Now we have to figure out the a squared and b squared values that are going to go in the denominators here. So in the x direction, the a value is given by the distance from the center to the vertex. So if we count that, that's 1, 2, 3. So if a is equal to 3, that means a squared is equal to 9. In the y direction, we do the same thing. Our b value is the distance from the center to one of the co-vertices. This is a distance of 1. b squared is 1 squared, or just 1. So this would be the equation of the ellipse. Number 7, we're asked to graph this equation. We have a parabola. One of the variables is squared, the other variable is not squared. Our vertex here is at 1, -1. This is x minus h, and this is y minus k. So let's plot that first. And in order to determine where the focus is, we need to know what the p-value is. So this a value, -1/20, is equivalent to 1/4p. If we solve this, we get that p must be equal to -5. So the p-value here is -5, and that's defined as the distance from the vertex to the focus. So let's look at whether this is a horizontal or vertical parabola. Since the y is being squared and the x is not being squared, this is a horizontal parabola. And that means we have to count -5 in the horizontal direction to get our focus. So I'm going to count -5, so left 5, to identify where the focus point is. So we can say now that the focus is at -4, -1. And because our focus is 5 away from the vertex, that means the directrix is also 5 away from the vertex in the other direction. So we can fill in the equation of this line, the directrix at x equals 6. Or, yes, x equals 6. The parabola is going to open left because our vertex is here, our focus is here. And we can draw the axis of symmetry, which splits the parabola into 2 symmetrical parts. This equation is y equals -1. All right, in number 8, we have the equation of a hyperbola, because we have one of the variables has a negative coefficient, the other has a positive coefficient. So the center of this hyperbola is at -3, -1. This is x minus h, and this is y minus k. And because the y squared is the positive variable and the x squared is the negative, that tells us that it's a vertical hyperbola as opposed to a horizontal. So let's plot the center, -3, -1. And before we try to identify these other things, let's sketch the graph of the hyperbola. So first thing we need to do is determine where our asymptote lines are. And in order to do that, we're going to create a rectangle using our a and our b values. So here, a squared equals 16. That means a equals 4, and that's in the y direction. So I'm going to count up 4 and down 4. B squared is 4, so b is equal to 2 in the x direction. And that gives us 4 points to connect to create our rectangle. Using the rectangle, we can now draw our asymptote lines. And now we need to decide where the curve of the hyperbola is going to go. We decided it was a vertical hyperbola, which means the hyperbola curve is going to open up and down as opposed to right and left. And so now we can see that our vertices are here and here. One of the vertices is at -3, 3, and the other vertex is at -3, -5. Then to find the asymptotes of our hyperbola, the slopes of the asymptotes, let's look at the rise over run. Here we have 2 points on the asymptote line, up 4 over 2. So 4 over 2 is the slope of this line. But we also have this other asymptote which has a slope of -4 over 2. So 4 over 2 or -4 over 2, these both reduce. So we have a +2 or -2 is our asymptote slope. All right, and lastly, number 9 in this section, what is the a value of a parabola that has this focus and this directrix? Again, easiest way to do this, just like we did the equation of the ellipse, is to sketch what you know. So let's sketch our focus at 1, 1, and the directrix at the line y equals -3. Now we know that in order to write the equation of a parabola, you need to know the p value, p being the distance from the vertex to the focus. Our a, which is all we're asked to find here, is equal to 1 over 4p. So if I know p, I can find a. So if we're trying to find the distance from the vertex to the focus, well, we know the vertex has to be halfway between the focus and the directrix. So if I count here, that's 1, 2, 3, 4. So my vertex should be 2 away from the directrix, 2 away from the focus. This point is our vertex, so our p value is the distance from the vertex to the focus, which is +2, which means a is 1 over 4p. 1 over 4p is equal to 1 over 8.